Okay, so we're going to look today at solving by factoring. Okay, this is to put this in a little context. There's not really hardly anything new here. This is going to be an application of the stuff that we've done thus far in Unit 4. What have we done? Just factored, right? We've had 3 lessons on factoring. And this is where we actually get to look at why do we factor, okay, where we're actually going to use factoring to solve equations. Okay, we've mentioned this before, but let's just quickly take a look at the 3 steps that we're going to be applying in every one of these situations. When we want to solve by factoring, first thing we want to do is we want to put the equation into standard form, which means we're just going to set it equal to 0, right? Set it equal to 0. Then we're going to, step 2 is all the stuff we've been practicing. We're going to factor the whatever side is not 0, right? Probably the left side. Probably 0's on the right side of the equation. We're going to factor whatever we've got on the left side, and then we'll apply the zero product property. And here's a reminder of why that's so important. If you look at these examples, I double dog dare you to look at that top one and tell me what the solutions are. All right, you can't do it. You can't look at that and see what are the values of x that are going to make the left side equal 0 in the top example. You could be here forever trying different values, and you might never find them, right? Just by guess and check or something. Bottom one, piece of cake. If you're remembering how the zero product property works, you can tell them to me just like that. Maybe you don't. We'll review that. Can anybody tell me what the solutions are to the bottom equation? Maybe we have to do a little quick. Oh, you think you got it? What do you think? Okay, it's close. It's close. We're getting closer to the answer. Let's do a quick mental warm-up again. I'll just remind you guys about something. Multiply these numbers in your head, please. 47.5 times 93.124 times 0 equals 0. Okay, right? So the only way we can multiply factors and get a result of 0 is when we multiply by 0, right? So how many factors are there in this bottom equation? It's happened to every period so far. This thing crashes. I don't know why. It's about ready to tear it off the wall and break it over my knee. How you doing, Gabe? Good. I looked up and saw you out there. I just have a little conversation while we're waiting for this thing. Okay, here we go. Okay, back to this. Right, so top one, we can't solve by inspection. We can't just look at that and see the answers. But the bottom one, we're going to be able to really quickly. How many factors are being multiplied together in that bottom equation? 3, actually 4. I know what you're thinking. You're on the right track. This is really a factor, right? So this is, how many factors are there? Well, there's 1, 2, 3, and 4. You were just counting those 3, weren't you? Yeah, and those are the important ones. So the only way that the product of those 4 factors could be 0 is when one or more of the factors are equal to 0, right? Well, the 3 can never equal, 3 is 3, right? That's a constant. There's no value of x that's ever going to make the 3 equal 0. But each of these other factors all have a variable in them, right? So we should be able to choose the value of x that's going to make each of those other three factors become 0, right? What's the value of x that makes that factor 0? Not 0. If I plug 0 in for x, I'm going to get 0 minus 2 is negative 2. 2, there you go. Okay, so if x equals 2, look what happens. I'd get 3 times 0 times, who cares? The answer is 0. I've multiplied by 0, right? What's the value of 0 that's going to make that factor 0? Negative 5. Okay, and then I get 3 times, if I let x equal negative 5, I get 3 times negative 7 times 0, done. It's 0, right? And then finally, what about that one? That one's a little bit tougher, but there's a trick we can do here. We can always, let's go ahead, what is it? Negative 1.5, so negative 3/2 we could say, right? How do we get that? Well, we probably could do it in our head, but let's do it, let's write it down this one time. If I want to know the values of x that are going to make this factor equal to 0, here's how I ask the math gods. I just set the factor equal to 0 and solve, right? What would the 2 steps be to get that x by itself? Subtract 3 and then divide by 2. So look, we end up getting x equals negative 3 over 2, right? And we probably could have just done that in our head, right? Okay, so those are the 3 values, done. Okay, why was that so easy down here? Well, it's so easy because it was factored, right? We could use the 0 product property there in that bottom example because it is factored, right? That's the whole key, is we got to get it into that factored form first, and then it's easy to just ask, okay, what are the values of x that are going to make these zeros, these factors become 0, right? Okay, let's practice this. So what about this one? Right now, we can't just see the answers. We got to break it apart into a product of smaller factors. How can we factor this? What would we do? Okay, good. We could undistribute a 4x. There's a greatest common factor, isn't there? So we get 4x is my GCF times what? Well, if I want to find out what's left behind, if I divide that 4x out, factor it out in front, this is just like dividing each term by 4x. I'm dividing it away, right? So what's 4x squared divided by 4x? X. 12x divided by 4x? 3. And look, we got it. Now it's easy. Now I've gotten this thing broken up into a product of 2. I'd call these linear factors. Why are they linear? Because think about lines. Y equals mx plus b. The x is to the first power, isn't it, right? So that's linear. These are linear because the x's are to the first power. They're easy to solve, right? Linear equations are a piece of cake. Isolating, I bet that you wish you could go back to those days, right? Solving linear equations is simple. So we can do it in our head. So what are the values of x then that are going to make these 2 factors equal 0? Negative 3 from this one. And then 4 times what would give me 0? 0. There we go. In fact, anytime we have a monomial factor, meaning it's only got one term, right? Like a GCF or something, right? What's the solution going to be? 0. Every time, isn't it? Okay, good. Give me a 1 to 5 real quick. People online, just type it in chat. Give me 1 to 5. Okay. All right, so we're moving along. That's fine. We'll get a lot more practice. Okay. How about this one? Okay, good. I could factor out a 5x, couldn't I? First step. There's our greatest common factor. So what's left over from that first term? If I undistribute a 5x, okay, good. The 5's cancel. X cubed over x is x squared. And then here the x's cancel. And 405, what's that going to be? 81. Good job. Okay, good. We're getting there, right? That's better. It's looking easier. I already can see one of my zeros is going to be x equals 0, right? That's one solution to this equation. What about this one? So we got to go a little further with that one, right? That looks familiar, doesn't it? That we can factor that. That's x squared minus a number. There's a pattern for that, right? There's an app for that. That's the a squared minus b squared, difference of squares pattern. How did that factor? You remember what that pattern was? A squared minus b squared factored into what? There you go. Good. A minus b times a plus b. And this is really just, I can already see that I've got an x squared. 81 is just 9 squared, isn't it, right? So we can think of that as a difference of squares. And then look what happens, right? We've now got 5x times, if I split that apart, that's x minus 9 times x plus 9, and the whole thing equals 0. So what are my solutions? Yeah, I'm getting from this factor, I'm getting 0. That's the value that makes that one 0. This factor, I get 9. And this factor, I get negative 9. Easy to check too, right? All I'd have to do to check this on a test is just plug those values back in for x up here and just verify that they work using a calculator, right? Okay. Ooh, what's different there? Yeah, it's not equal to 0, is it? Let me see, did I skip one? Oh, don't break on me, come on. I'm not hopeful. Of course. Yeah. 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 No, but we had 3 show up last time. I think there's a lot of athletic stuff going on too, but then there's a lot of people who just don't show up, you know. All right, let's see if this saved it for us. How'd we do here? Oh, okay, we're good. Yeah, we're back. Okay, so yeah, what's the problem here? It's not equal to 0, right? That was our first step, is we have to get these things in standard form. We got to get them equal to 0. So how are we going to accomplish that? Which side should we push everything to in this? Good, you're right. What's your thinking about that? How come, Shevana? Okay, good. We'd have a negative coefficient of x squared. We want the coefficient of x squared to be positive when we're factoring. Makes it easier, right? So we'll push everything over here, right? So on either side, we're just going to subtract. We're going to subtract x squared, subtract 10x, and add 72, right? And what's that give us then? Well, we're going to get 2x squared minus x squared is x squared. Negative 7x minus 10x is minus 17x, and then just 72 equals 0. Okay, good. All right, so we got a trinomial that we could factor now. And so this is one of those where if I have a quadratic trinomial, 3 terms, and a is equal to 1, these are the easy type, right? These are going to factor easily, or maybe they won't. Okay, but if they do, it's going to be easy. So we know that in order, if I multiply these things out, the only way I'm going to get an x squared is if that's an x and that's an x, right? We just got to find the magic numbers, okay? Are we guaranteed to find them? No, we're not. They may not exist. Didn't we have one like that? Last time we met, I think we had one like that where there were no magic numbers, right? So we may not find them. If they're too hard to find, we may not even choose to find them. Let me put this in a little context. Where are we going this unit? What's our goal this unit? Our goal this unit is to be able to solve any quadratic equation I throw at you, you can solve, okay? How do we go about doing that? Well, there's a variety of techniques. This is only the first of 3 or 4. I'll show you 4. We'll probably only end up using 3 very, very reliably and very frequently. So there's 3 different strategies we might use, and we're always going to pick the easiest one, right? We're going to, and I'll tell you what, the last one I teach you, do you guys remember the quadratic formula from Algebra 1? Vaguely, a little bit. You may not. That's okay. We'll go through it in detail. But here's what it basically is. The quadratic formula says that if I have any quadratic equation in standard form, I can just plug the values of A, B, and C, the coefficients, into a formula, and it's going to spit out the solutions, right? So it works every time. There's no time it doesn't work. So why would we not use it every time? Well, the reason we wouldn't use it every time is because it's not always so easy to use. It's not terribly difficult, but it's got a square root in it. There's a lot of computations to do. Sometimes it's easier to use other methods, like factoring, in this case, is the easiest by far. It's the quickest and the easiest and the least likely you're going to make a mistake using it. So why wouldn't we use it? We do. That's what we choose to do. But you're going to have the freedom in the future of saying, nope, I'm going to not factor that. It looks like it's too difficult to do. So we'll just bypass it and move on to another strategy, right? Unfortunately for you guys, this section is about solving by factoring, so I'm going to force you to factor so you get good at it, right? We're going to over practice factoring so it gets easier. But later on, you won't always even have to do it this way, okay? All right, so we got to find magic numbers here now. What would the magic numbers have to do? Multiply to 72 and add to negative 17. So what would the signs of the two numbers be then? If they multiply to a positive and add to a negative. Both negative, good. And what would they be? What numbers multiply to 72 and add to 17? 9 and 8, there you go. See, look how easy that was, right? Factoring here was definitely, that's a lot easier than having to crank through the quadratic formula, okay? And you'll see later on. So what are my solutions then? There you go, 9 and 8. Okay. Now I want you to notice there's a common mistake people make. Don't overgeneralize here. Don't make the mistake of confusing the magic numbers with the solutions, right? The magic numbers were not the solutions. The magic numbers were negative 9 and negative 8, and the solutions were positive 9 and positive 8, right? The magic numbers are the numbers you use to create the factors. The solutions are what you get when you set the factors equal to 0. You apply the zero product property, okay? You can see a connection there. The connection being that the magic numbers in this case, when we've got A equal to 1, right? The magic numbers are always the opposites of the solutions, aren't they? Right? It gets a little more complicated when you have to use slip and slide. Okay. Questions? So far, so good? Okay. Any questions online, crew? Any questions? Okay, no, all right. Okay, how about one like this? I just want to remind you about something here. This is not like there's anything really new here. This is something we did earlier in the year, but I don't want you to forget this cool trick I showed you. So we've got an equation. It's in standard form, but the problem is, look at the coefficients here. This is the same thing. Z squared over 6 is the same thing as 1/6 times z squared, right? I could, if I wanted to, rewrite this as 1/6 z squared minus 5 halves z minus 36 equals 0. Those are not very convenient coefficients to factor, are they? Right? So we don't want to do that. We want to get rid of those fractions, right? How did we do that? If we had an equation that involved a sum of a bunch of terms like this, where we had fractions, we had a really cool method for clearing the fractions. What did we do? What did we do? And online folks, you can chime in on this too. What did we do to clear fractions?
Do you multiply it by like the greatest common factor?
Okay, you multiply, very close. You multiply, I know you're thinking the right thing, Tony. You multiply by the least common multiple. Think of it as the common denominator, right, of all the fractions. What's the least common denominator of all the fractions? In other words, what's the smallest number that all the denominators would divide into evenly? So not 2, because 6 doesn't divide into 2. 12 would work. 6, but 6 would be better. We want the smallest one possible. 12 would work because 6 and 2 divide into 12, but 6 is the best option because 6 is smaller, right? Okay, so we're going to multiply through here by, let's see, we're going to multiply through by a 6. All the way through both sides. And remember, if I've got an equation, as long as I multiply both sides by the same number, that's fine. I can do that to an equation, right? You got to treat both sides equally. So I want to remind you about a little trick here. So one thing I could do, if I distribute the 6, I would get 6z squared over 6 minus 30z over 2, because I just multiply straight across, don't I? It's like 6 over 1 when I multiply by 6. You multiply fractions straight across. So minus 30z over 2. If I distribute the 6 all the way over to the negative 36, I get minus 216, and anything times 0 is 0. And then I could just reduce the fraction. 6 over 6 is 1. 30 over 2 becomes 15, right? And now it looks better. But you might remember, I showed you a really good trick here. I was full of tricks early in the year. We automatically know that all of the denominators are going to divide into this number. That's why we picked it. So we always know that instead of multiplying first and then reducing, we could just reduce the fractions first and then multiply by a smaller number, right? Remember that trick? So 6 over 6 is 1, which I would multiply by the top, right? And so that just gives me z squared. 6 over 2 is 3, which I multiply by the top and get minus 15z. 6 times negative 36 is negative 216, and then 6 times 0 is 0. So there we go. Get there a little quicker that way, okay? So now this is good. Now I've got a trinomial where a is equal to 1. So all I've got to do is find magic numbers, right? My magic numbers this time, would everybody agree? They have to multiply to negative 216. And they have to add to negative 15. So when I factor this, I know that those are z's. Instead of x's this time, we're using z's, no big deal. If they multiply to a negative, I've got opposite numbers, one positive, one negative. They add to a negative. It means I have a big negative and a small positive, right? We just got to find those guys. These are big enough numbers that maybe it makes sense here to make a little table, right? So we could do this two ways. We could make a list of numbers that multiply to negative 216 and then just pick the ones that add to negative 15, or we could make a list of numbers that add to negative 15 and pick the ones that multiply to negative 216. You pick, right? In this case, I think it's a little bit easier to do the second one. I think we'll pick numbers, call them m and n, that add to negative 15. And then over here, we'll calculate what do we get when we multiply m times n, because we want that to be negative 216. So for example, numbers that multiply to negative 15. would be negative 15 and 0. Well, that's no good, obviously, right? Negative 16 and 1, negative 17 and 2, and so on down the list. I've got to keep going until I get numbers that multiply to negative 216. So I got to go down a ways, don't I? So let's skip down the list. If I skip down to, how about if we skip down to something like, negative 22 and 7? See what we get. That's right, isn't it? Those add up to negative 15, okay? So that's going to give us negative 154. We're getting closer, but we better keep going. I'm going to drop down to negative 24 and 9. What's that give? That's it. 9 times 20 is 180. 9 times 4 is 36. 180 plus 36 is 216, right? So there's my negative 216. And my numbers were negative 24 and positive 9. So then what are my solutions? There we go. Z equals 24 or Z equals negative 9, right? Okay, was that more trouble than it's worth? Maybe. At the end of the unit, you might decide, those numbers are too big. I'm not going to find magic numbers. I'm just going to put it in the quadratic formula, okay? Okay, what about this guy? What should I do here? Okay, good. Let's push the negative 8x squared over to the right so we have a positive number of x squared. Good idea. So we'll do this. And that's going to give us a positive 8x squared minus 22x minus 21. And then I'd have the 0 over on the left, but let's just put it on the right. Doesn't matter. Put it there. Okay? So here's an example of a problem where, and I can't factor out a GCF, can I? Everybody agree? I'm stuck with that 8. So here's one where we'd have to, these are the harder ones to factor. A is not equal to 1. Are we going to do this at the end of the unit? Probably not. Probably not. If we've got a factoring problem where A is not equal to 1, we'll probably just bail on the whole idea of factoring and do something easier, right? Okay, but we're not there yet. So for now, we've got to factor this. So take your pick. I'm assuming you guys probably like slip and slide the best. Is that okay? So let's just do a little side work here. We'll go over to the other side of the board. And our goal here is we just want to get this thing written as something times something equals 0. And to get there, we're just going to use slip and slide. So slip and slide. Remind me. What do I do? What's my first step in slip and slide? Good. So we slip A to the end and multiply by C, right? There's the slip of the slip and slide. So that gives us x squared minus 22x minus 8 times 21 is 168. Okay, so now look what that did. I've got an easier trinomial to factor. A is equal to 1. So this is a basic trinomial. So we got to factor this thing, right? So we've got to find magic numbers that, what do they have to do? They have to multiply to negative 168, and they've got to add to negative 22, right? Okay, so we know that they're going to be, the big one's going to be negative, and the small one's going to be positive, and we could do the same thing. We could go through a table like that. I'm going to make this kind of quick. I don't want to get too bogged down on this. So we'll make a list of numbers that multiply to negative 22. Well, let's jump up to something like negative 27 times 5. Okay, that's going to give me negative 1 35. Okay, we got to go a little further. We got to get to 178. Well, that's pretty close. Let's try negative 28 times 6. That's it, right? That gives me negative 168. You see how I'm getting these numbers? I'm just picking a negative number that's 22 bigger than the positive number, right? To find numbers that add up to negative 22. Okay, so we got x minus 28 times x plus 6. What's my next step here? What's step 3 in slip and slide? What did I do? You do. Good. So you put not in the front. We're going to divide each of my magic numbers by 8. And then what? Simplify them. Good. We'll reduce those fractions. Well, 4 goes into 28 and 8, right? So I could write that as I can divide them each by 4 and get 7. Oh, my goodness. Get 7 halves. There we go. And here I can divide by 2 and get x plus 3/4. And then last step, slip in, slide. What do I slide? There we go. I could slide the 2 up front and slide the 4 up front. And I get 2x minus 7 times 3x plus 4. Those are my factors. There we go. So 2x minus 7 times 3x plus 4. And now I just apply the zero product property, right? Set those equal to 0 and solve. So notice here, if I set that equal to 0 and solve for x, how do I get the x by itself? Okay, so I got to add the 7 to the other side and divide by 2, okay? Or here, gosh darn it, if I want to solve for x, I'm going to subtract the 4 to the other side and divide by 3. Well, I want you to notice something, right? Are we good with all that? I want you to notice something. There's a little trick here that sometimes people use. Look at this. Look at that factor right there, that orange factor. I didn't even really need to do the slide part, did I? Right? I can see that, look at this, the 0 of that factor is going to be 7 halves, right? And look at this one right here. The 0 of that factor is negative. Oh, did I do that backwards? Oh, I did. Look what I did. I wrote these down wrong. Whoops. Let's fix this. This was supposed to be, I put the wrong number up there, didn't I? That was supposed to be a 4x plus 3, right? And this was supposed to be a 4x plus 3, which makes this, I got the wrong answer. I wrote something down wrong. So to solve for x, I would have to subtract the 3 and divide by 4, right? But there's my negative 3/4 right there, right? Okay, good? All right, we're out of time. That's good. We don't need to do this last one. But if I did this last one, all I would have to do is break this one up into 2 factors and this one up into 2 factors, and then apply the zero product property, right? Okay, good stuff. All right.